For the next question, what we will do, we'll build a stack again, but instead of array now we are using the linked list. So I will just tell the brief about stack. Stack is linear data structure that is like last in, first out, follows the LIFO structure. And now we are, instead of using arrays, we can implement the stack using linked list, which is like more dynamically memory allocation and avoids like overflow issues. Like we earlier we have to make an like initialize it the array with a proper size, like a constant size of 5, but instead of that we avoid that in with when we are using the linked list. So again we are implementing the all the operations like push, pop, peek, and is empty, and also like just displaying that particular like stack. Because the insertion and deletion at the head of linked list takes O of one time, and like no shifting of elements like array, that's why we are using like linked list to build the stack. So firstly we will just define the node, and in this we are just defining the node, and as suggested we are just saying that the top of the node is equal to null, that the stack is empty. And the logic of push operation is simple, like we are just creating a new node and pointing its next node to the current top and update the top. So like new nodes next is equal to the top. And similarly, the pop operation, what we are doing is check if stack is empty. If the stack is empty, we will just say that stack is underflow. And if it's not, then we will just store the top node and move the top to the top's next and delete the old node. And for the peek operation, we are just checking the stack is empty and returning the like the top element. And for the is empty operation, we can just check that return top is equal to null, then it will show that the stack is empty. As we are just like if our stack is empty, we can just say that like stack is empty. And we also just dry run this solution. Supposedly what we have right now is, suppose our top is equal to null, and then we push 10. So like top 10, like top is equal to 10, and then 10 tends to null as one linked list. And then again we push 20, so it's like top 20 10 and null. Then we push 30, so it's like top 30 20 10 and null. So when we will display it, it will print like 30, 20, and 10. I will also try run this solution. It will give us the same result as before. So here you can see. And afterwards, like when we are just removing, like it will print the top, like if we are just printing that peek function, it will call the peek function and print 30. So the top element is 30 from the stack, and then we pop out, so it will pop out the element that is on the top of the stack, that is 30. And then and we display the function afterwards, it will just print only 20 and 10 as 30 is already popped. And the time and space complexity of all the function is O of 1, and time complexity is O of 1, and the space complexity is O of n, as we are like moving through the length of linked list.